Hi all, my name is Mads Barnkop from Kaizer Power Electronics. Today we're rebuilding the old variac, the three-phased variac that you saw did not work in my washing machine video. I have cut up the whole enclosure, cut off all the plates to fit, and now we're going to build this multi-measurement voltage and current data monitor into it. Make some soft start circuits, make some safety circuits. So let's look at the parts I'm going to use and the schematics. We have the data monitor, which takes 3 current monitors, and I also have my voltage step-down transformers here for mains voltage and current up to 32 amps. A 32 amp IC connector. Probably going to change that to some other types. We have a control voltage transformer, 24 volt AC. A just large disconnector. Got some lamps and some push buttons that I want to use to make a self-holding circuit with these contactors. And we want a soft start mechanism, where I found out I had these nice inrush current contactors made for it. Came from a PFC power factor correcting system, which could use these built-in resistors to couple the inrush current of the power factor correction capacitors. So overall total reuse, all the items here are previously used, so it's a good project to use some of all the parts I have here in my workshop. So let's take a look at the schematic. I have the main voltage come in through the disconnecting switch. We have the first contactor, which will be the safety part, which means that it won't just put out power as soon as I turn on the switch or put the plug in. That this has a self-holding circuit with a start switch to a third relay, which then couples in the first relay and also supplies power to a timer. This timer then couples in the second relay. This relay has the built-in resistors over it, so once that goes on, the resistors are bridged over and we no longer have soft start. Here on the output we have the voltage step-down transformers and the current transformers, and we have our output. It's all wired up now. I did do some checks with the multimeter along building it, just with this one. And there I did find out that this terminal block on these reused relays from the capacitive switching bank, they're actually normally open and not normally closed as I assumed. So I'll have to switch out those resistors and that terminal block with some larger power resistors. But the overall function of it is according to plan. So let's just switch on the 230 volt AC control voltage, and we can hear a slight hum from the contactors. The red light goes on, which means it's not ready, whereas the turned off means there's full power. So this indicates full power when it's completely turned off, and you can just look at, is there any wires in? No, it's not. But if there's wires in and this is out, then there is full power. Now we have the start button. We have our timer relay here set for 5 seconds. When we press that, we have a 5-second timer for the resistors to charge up capacitance in the Tesla coils, and it's now in its dangerous state. The lights are off again. So let's just try that one more time. I'm putting on power. Now over here we have the timer. Now I don't have the high voltage or the mains voltage on this, only the control voltage. So we have the current transformers. I have to get these bolted onto the bottom plate here. We have the voltage measurement on the custom PCB over here with step-down transformers. And this contactor over here with the resistors, I have to replace that for some larger power resistors. So again, if I press start button, contactor 3 is shut in along with contactor 1, and then contactor 2 is on the timer. Now the data monitor is not hooked up yet, because that will only make sense once we have the 3x400V AC mains supply on it. To make a test of the new soft start box, I have planned to do a static load test first to test the load current up against the data monitor, if that is somewhat precise. And I will do that with a just 9 kilowatt heater sitting down here. And then afterwards the soft start will be tested with my DR SSTC 1 Tesla coil standing here. So we'll just try to charge up the DC capacitance and see how that goes, and if we can get a reasonable graph on the data monitor. Alright, so let's start the soft start. I'm not going to turn on the load, as the balancing resistors or the soft start resistors are not rated for starting up a 10 kilowatt resistive load as the heater is. So let's just start it, and we can see the voltage climb up. We are having 405, 401, 408, and over here I read out 406. So voltage stripped down transformers are doing its job. Okay, so let's just zoom in here. So once the soft start has been switched in, I will turn on the heater and we'll see, I think we should get something like 12 amp load current per phase here. First I'll try the low setting. That's only two-phased. And we see we're having 11 amps per phase. And full load gets up to around 12.5 to 13 amps per phase. So that corresponds between the measurement and what the heater is actually rated for, and I have 30 amps over here on the other measurement. Let's just check that out. And as we can see here, we have the same thing, 400 volt AC, 13 amps, 9 kilowatt. So data monitor voltage and current measurements are spot on. This is the soft start test on the Tesla coil. As we can see, it's only running at 1 minute per division, so the resolution is of course not that great. But I will turn on the driver on the Tesla coil, which will be a bit noisy because of the fan, and then start the soft start, and we should see the voltage curve and current curves. Not sure what I expect, but let's see what we get. And soft start now. Yeah, so that went very fast. As we can see, it's just a soft curve here, and the resistance could probably be much greater on the soft start resistors. It's only 225 amps. And right now, where it switched over after 30 seconds, we can see there were really no additional capacitance on the DC bus to charge up. So for this Tesla coil, it worked fine. Thank you for watching. This was a rebuild of a previous project, and I used almost reusable parts from teardown videos. So overall, I'm very happy about using a enclosure, screws, components. Even the wiring from the old variac has been reused. So I put almost no new components into this build. I hope it also inspired you to build more safe parts in your projects. Something like self-hold start switches that will turn off and does not automatically turn on once power is restored, and that you also put in some soft switching and some measurement circuits. So until next time, see ya.